APBC Calculus students, in this video I'm going to explain how to answer parametric free response questions, and most of them calculator is allowed. So I will show you how to use the calculator and how effectively and efficient you should be in this type of questions. So let's take a look at this example 5. Object is moving along a curve on the xy plane. As usual, position is x and y. Dx dt is given and dy dt is given to you. So know that the velocity vector is given to you. Think of that as a velocity vector is given to you, which is sine of t to the third and cosine of t square. At t is equal to 2, object is at this. So this is the position vector. Think about this is the position vector given to you. At t is equal to 2 minute, position is x coordinate is 7 and y coordinate is a 4. Okay, so the first thing you should do it, if its calculator is allowed, so straight away first thing you should do is put in a calculator y1, y2. We are going to use a function mode. Parametric equations, you do not need to use parametric mode, just we are doing twice. We do the problem twice in a function mode. So y1 is, make sure you know the order, sine of t to the third, and y2 is cosine of t square. Put this in an equation in a calculator, y1, y2. So let's read this first equation. Write the equation of tangent line, t is equal to 2. So note that the equation of tangent line is y minus y1 m x minus x1. T is equal to 2. You are given the position. Position is already given to you, t. So this is your x1 and y1, which will be y minus 4 x minus 7. The slope at t is equal to 2. So note that the slope is dy dt over dx dt. So you are already given this dx dt dy dt. So all you have to put in this substitute, cosine t is equal to 2 is a cosine of 4 and sine of 8. You do not need to use a calculator. Even if it is allowed, you do not need to use cosine 4 over sine 8. And this is your equation of tangent line. You are done. Even if calculator allowed, you do not need to show. Now, if you insist to use the calculator, then I'm giving you the calculator. Answer is, you will have to do this on a manually. You can go on the home screen on the calculator and you can show that sine 4 over cosine 4 over sine 8. Answer is, this is the calculator answer, but this is not necessary. You can show here and you are done. Okay, so let's take a look at the second part. Second part is asking for speed at the vector, speed of the vector at t is equal to 2. So let's take a look at what is the speed is the magnitude of the velocity vector. Speed is the magnitude of the velocity vector. Velocity vector is given to you. This is x1, y1. So this is x prime of 2, y prime of 2. Unfortunately, this is not acceptable. Find speed means you have to substitute and actually find the speed. What will be acceptable is, let me show you, if you keep substitute 2 here, which is sine of 8 square plus cosine of 4 square, this is a valid answer. They have to give you 100% credit. This is 100% correct answer because there is no number there. But if this is a multiple choice question, I would like to show you how to use the calculator. So let me show you on the calculator. This is my sine x to the third, cosine x to the second. So let's come back on a home screen. And how do you find the speed? First thing, let's put the radical. Then I need to put the parenthesis alpha trace, which was your y1, parenthesis 2, and I have to square, plus alpha trace y2, that's my second equation, parenthesis at 2 and square, and then enter. So this is the speed. Now calculator answer must be at least 3 to 4 decimal places. I prefer 4 decimal places. So let's take a look at one more time here. If you keep this, is perfectly all right, or you have to write 1.57. This is the speed. Not all the time this is that easy. Sometimes it's very complicated, so you have no choice but to use the calculator. Okay, so let's take a look at how do we find the acceleration vector. So let's read this question carefully. What values on the interval 0 to 1 does the tangent line of the curve has a slope 4? Find the acceleration vector at this time. So this is a two-part question. First part is to find the time t, and the second part question is find the acceleration at that time. So let's take a look at slope equation. Our slope equation is cosine t square over sine t cube. This is a slope. dy dx is cosine dy dt over dx dt is equal to 4. So you are given that cosine t square sine t cube is equal to 4. You have to find t is equal to. So in other words, you have to solve this equation and find the t. Remember, we have a calculator, so we are going to use graph and intersect. We are going to use graph and intersect. So y3 is equal to, we are going to use the calculator and we are going to put y2 over y1, and y4 is equal to 4, and we have to store that t value. So let's take a look at how do we use the calculator. So go back on the here, y3 is equal to alpha trace y2 divide by alpha trace y1. You can switch off these two graphs. You don't want to graph all of them. You want to switch it off. And now y4 is equal to 4. You want to graph this between 0 and 1 only. So I'm just going to put zoom 4 because as long as okay, so I don't need to see all of this. So I'm going to again zoom between 0 and 2, let's say. I need to find the graph and intersect. Okay, so you can clearly see between 0 and 1, that's my intersection. Okay, so let me change the window again because that's a 4. So y max is, let's say 6. All I need is the intersection. Okay, so I'm interested in 0 to 1. This is the intersection I have to find. So second and trace, number 5. Go closer, somewhere closer to the intersection. Okay, 1, 2, 3. That's the t value where the slope is 4.616. You have to find the acceleration at this time. So come back on a home screen, temporarily store that value. Let's check it out. That's a 616. Store as alpha a. Okay, so this is my t value. I'm going to write down here 0.61648. So yes, 0.616. Normally there is a rubric that you get a 1 point if you find the correct t value. So I'm just let me 61648. So 61648. to find the acceleration at this time t. Let's find the acceleration at this time t is a of 0.616 is, what's that going to be? You don't have to show by hand. You are not going to find the derivative by hand and substituting. Let's take a look at this calculator again. You are going to find x prime prime of 0.616 and y prime prime of 0.616. This is just the setup. You need to get the answer. So let's take a look at again calculator. Okay, so remember for here you have to find the derivative. So math 8 dx. Here you need y1. That's your first one. At alpha a. This is your x coordinate of the acceleration vector 1.109 comma. Okay, so repeat the process again. Now here is the thing, it's so much easier. There is a hint that if you do second and enter, you get the previous entry back. All you have to change is this needs to be y2. So alpha trace, change y2 and enter. This is your y coordinate of the acceleration vector, which is negative 0.4573. One more time, this is a calculator active question. Your calculator skills needs to be tested here. How do you understand? Slope is a 4. You must show this. Slope is a 4. Find the t, store the t, find the acceleration at that t. Now the last part is a position of the particle at t is equal to 1. Okay, so position at t equal to 1, you must consider initial position. This is the most, usually this has a 4 points or 3 to 4 points. Usually this has a more points. So initial position is given to you. T is equal to 2. Object is at 7 and 4. You have to consider this. Then you want to find that t is equal to 1. So you are going in the back. So must show the setup 1 to 2 x prime of t dt is equal to x of 2 minus x of 1. Net change in position. You integrate the velocity, you get the net change in position. Using this one, I want to find that x equal to 1. So what will be x equal to x of 1 is, what will be x of 1 will be x of 2 minus integral 1 to 2 x prime of t dt. Okay, so then all you are doing on the calculator and show the work. So let's take a look at how do we do it. So I'm going to move this calculator here. I have to find x of 1. So x of 2 is 7. Let me write that. This is equal to 7 minus integral 1 to 2 x prime of t dt. Okay, so let's use the calculator and get the answer. So 7 minus math 9, 1, upper bound is 2. Remember x prime of t you have already stored in y1. So alpha trace y1 and x. This is your setup part. Always there is a 2 points, one for the setup, one for the answer. So what will be the position? This is the position 6.782. 7818, or there are only 2 answers possible. 6.782. They only accept these 2 answers. So one more time. Initial position, this is your x1. This is your y1. You have to know how to find the position at t is equal to, no, this is 2, sorry, this is x2, y2, I'm sorry, it's x2, y2. So again, repeat one more time, change the color one more time, 1 to 2, y prime of t dt is equal to y of 2 minus y of 1, net change in the position of the y coordinate between 1 and 2. You have to find y of 1, which is y of 2 minus integral 1 to 2 y prime of t dt, and you are going to use the calculator again here, 1 to 2 y prime of t dt. I already showed you how to do it. If you want to check, let me show you what my equations are. Equations y1, y2 are already stored. They are inactive, but that doesn't matter. They are already stored in the calculator. So here, second n, enter. You get the previous entry back. You can just go back and change the numbers. You don't want to do it again. This is a 4. Let's scroll on the side. This will be my y2, alpha trace, y2, enter, enter. This is y coordinate, which is 4.443. Now you don't have to put them together. It's not necessary to put them together. If you want, yes, you can write your answer that S of 1 is, this is not necessary, but it looks nice, that the answer is 6.781 and 4.443. This is the position at t is equal to 1. So practice using calculator for the next 2 examples. Now the next example I was going to show you was example 7. I will try to do, I'm going to walk through. Most of the material is, most of the concept is the same. This is very similar to the example 5. You can put this in y1, this is y2, store in the calculator. Very similar question. This is very similar. I'm not going to do this one for you. I would like to show you the distance traveled. Let's talk about that. Distance traveled. Distance traveled is the same as arc length. Distance traveled is the same as the arc length, which is 2 to 7 something square plus something square dt. Remember, this is everything is in dt. Now what goes inside is your x1 and y1. So this would be t sine t, and this will be cosine t square. Okay, so how do you evaluate? This is not only for the setup, it's asking for evaluate. It's asking for evaluate. So same thing, you have to put in a calculator, square, x1 square, y1 square, radical, and then you evaluate. I'm giving you the answer, 13.2294. All these notes are posted in the notes. You can check that. Displacement is displacement. Let's talk about the displacement. Know the difference between distance and displacement. Displacement is simply 2 to 7 x prime of t dt. This is a displacement, and the same thing you have to do it 2 to 7 y prime of t dt. So what this shows is how much the particle has moved between 2 to 7. So using calculator again, 2 to 7 x prime of t, this will be negative 6.6362, and this would be 0.9687. Now of course you have to change in the equations in the calculator, but I'm just walking you through what to do here. Position of the object is very similar to the example 5. Make sure you know how to do this and check the answers. So practice on example 7, which is very similar to example 5. Now one more question I was going to do, it was example number 8, which is a little bit complicated. So I'm going to walk through again example 8. So let's talk about this. This is slightly different. The object moving along a curve position, right, normal xt, yt, they only give you dx dt. Derivative of dy dt is not given. This is a classic College Board trick that they give you only one of the equation, they do not give you another one. They still gave you position. So this is, you will see the similarity between 5, 7 and 8. 5 and 7 were very similar. Number 8 is they just did not give you dy dt. Position is still same. One part of the velocity vector they gave you. So let's read this. Find the x coordinate of the position of the object at t is equal to 4. Notice that they only ask you x coordinate. They did not ask you y coordinate because finding y coordinate is not possible. Finding y coordinate is not possible. That's the reason they did not ask for y coordinate. So x coordinate position means finding derivative, remember, between 2 to 4. X prime of t dt is equal to x of 4 minus x of 2. And this is your x of 2. You have to consider 3. Now in this case, you have to add because you are at 2 and you are going forward. You are going forward at t is equal to 4. That's the reason we are adding 3. 3 plus 2 to 4 x prime of t using calculator. Now I'm not going to show you again in the calculator. I'm just going to walk through the nuts and bolts of this question. So showing what work you have to show. Set up 1 point, answer 1 point. That's a 2-point question. This is. Okay, so let's read B. B says t is equal to 2. dy dt is -6. So they gave you only vertical velocity at 2 is -6. They did not give you the equation. Again, notice dy dt is equation is still unknown. They just gave you one value, that dy dt, that means y prime of 2 is equal to -6. That's only given to you. Write the equation of the tangent line to the curve at this. So what equation of tangent line is y minus y2, slope x minus x2. Remember, slope at x equal to 2 is already given, position of x equal to 2 is already given to you. So this is going to be very simple. Y plus 6 is equal to slope x minus 3. Now, how do you find a slope? That's very interesting question. So the slope is dy dx, and dy dx is, I'm keeping this answer. Slope is dy dt over dx dt. dy dt is -6. Dx dt is 2 times sine of 4. This is already given to you. Remember, dx dt equation is already given to you. 2 sine t square. The equation is already given to you. So you just substitute here and stop. You stop here. You do not do any work. You do not do any work. I'm sorry, this is 5, not 6. The slope is 6. Sorry, this is 5. This is correct. Y coordinate was 5. So slight twist here. They did not give you equation, but we can still answer these questions. We can still answer the questions. Now, the last part here is, let's take a look at this. Find the magnitude of the velocity vector at t is equal to 2. Magnitude of velocity vector at t is equal to 2. So know the velocity vector is, remember they already gave you -6. And this is 2 sine 4. How do you find the magnitude? Magnitude does not mean negative becomes positive. Magnitude means square add square root. Square add square root. So this is the magnitude of the velocity vector at t is equal to 2. This is -6 and the answer is 6.188. Remember, you don't have to get this answer. This is completely all right. This is correct answer as long as they are all the numbers. This stop here, stop. That's the, as long as they are all numbers, you stop there. Just show the setup. Do not need to, even if calculator is allowed, you do not need to evaluate, just as long as all the numbers, stop. Okay, so in this question, D is the most complicated one. So let's read D. T is greater than or equal to 3. Slope is 2t minus 1. Find the acceleration vector at t is equal to 4. So think again. You are given x prime. You know this. Y prime, you don't know. Is not given to you. But you know the slope. So can we find the y prime given the slope? Interesting, right? So let's take a look at here. I'm just going to clear here. So slope is dy dt over dx dt. You do not know dy dt. So if you solve for dy dt, then dy dt is 2t minus 1, which is the slope, times dx dt. So yeah, you can create dy dt. It's not that bad. Dy dt is equal to slope times dx dt. Slope times dx dt. So how do we use calculator here? It will take a while to put all these equations in a calculator. So I'm just going to walk through. You already have y1. This is a dx dt. Put the equation in a calculator. y1 is dx dt to sine x square. y2 is in the calculator. You put y2 is equal to 2x minus 1 times y1. You can do that too. y2 is 2x minus 1 times y1, or you can type it up, doesn't matter. This will be your dy dt. Now know that the acceleration means derivative. Acceleration means derivative. So all you have to go for math 8, find the derivative at 4, math 8, find the derivative at 4, and write in a vector form and done. This direction is for those who have older calculator, TI-83. You have to type it like this. So this was a slight twist in this question, but I kind of like it because otherwise this becomes so boring. All those parametric questions are very similar to each other. The twist is they try to change. Even one of the year they gave the graph, they give a velocity, x coordinate, horizontal velocity, they give you graph, and the vertical velocity, they give you equation. So they are just trying to put different twist there. So make sure you understand these 3 examples, 5, 7, and 8, and ask any question in the class if you have. Thank you.